because the students have the ability to go in and kind of move some things around here and maybe get a deeper understanding of how the functions work once they can see them, that maybe there's a way to build this into activities. I think the Desmos people had that same thought, and they built a platform for teachers to be able to build activities step by step that are custom made for themselves and for their students. And so here's the background. Math and project lead the way. Occasional tweets at the dull guy. And teaching thoughts fall out of my head and tweet me for no reason. So a lot of the teachers that were here for the first session, they're already one-to-one, didn't need much of an introduction to Desmos, but I was kind of surprised at how many of them were familiar with the tool at all. So that was a good place to start. So online graphing calculator, to the left-hand column with the plus sign, you can enter in functions, expressions, you can enter in tables, you can enter in images, you can enter in notes, text, so forth. Tools at the bottom can be minimized. And so in our first session, we thought about different ways teachers who had used Desmos have used it. And these were some of the things that I threw out to them. One was a check of student work, which you saw the lesson that you had observed, where we were able to kind of take a look at one particular function that they had some questions about seeing in an equation form. Once we took a look at it graphically, it started to make a little bit more sense. Students can use it to check their own work. Is this graph correct? We'll find out in a little bit that there's some sliders where students can change the values of, say, for instance, your A, B, and C in a quadratic. See how that affects the graphs. They can see that happen in real time. Desmos homepage has got an entire page full of links to art that students have created using the graphing tool. It's kind of fun. The Kahoot quizzes that I make, if I need a graph image, I'll go to Desmos, make that, take a screenshot, dump that in. So those are some of the common ways that teachers have used this when we talked about it in the first session. And these are some of the examples of artwork that students had done. The students create an account for themselves. They can submit these, and Desmos staff picks out ones that they really enjoy. You heard this morning about students having maybe other avenues to express what they know or express their interests. And here's art made out of functions. I think you probably had a long time ago done that piecewise function project. Make a face, make a penguin, make a bunny. When we looked at this in the first session, somebody recreated the Taylor Swift album cover in 1989. I was like, oh, how'd you do that? So kind of cool stuff there. And so this was the next logical step. So can we create an entire lesson based on these tools in Desmos? And can we let our students use the tools to get some deeper understanding of the math that we're talking about? And that's where activity building comes in. And they sum it up kind of nicely at the top. Handcrafted classroom activities. So these are all teacher created. And then some of them that get submitted, the Desmos staff will actually take and kind of tweak them a little bit and post theirs on their homepage so that anybody who's interested in using it can. Oh, you want to do that?
See those already teacher created?
Sure, let's go to teacher.desmos.com. So the biggest thing for me when I started using this was, how am I going to create an activity, right? From the beginning. And I think the biggest thing, the biggest leap for me, there was two of them. Number one was making sure that I knew what my objective was for the lesson, what I wanted the students to be able to do at the end, you know, and how to get them there. And so can I create a path to walk them from point A to B to C, or at least to let them walk themselves that way. And then, you know, the second biggest one was, you know, can I operate the tools? And really it was just a matter of, I'd seen a couple people who had done this, and I looked at what their set of steps were, what kind of slides they put together, and then let's just jump right in. Let's give this a shot. You know, my students aren't going to know if it's a good activity or not. It's from an aesthetic standpoint anyways. So this is how the progression looked like in my class. I had stolen this activity from one of my online teachers a couple of years ago, and used this to decent effect when we were at just the point where we're just about to introduce linear functions. Students that had already taken the class, some of those things were floating around in their head on form. So this was a good way to just kind of get a formative sense of, you know, how much of this stuff they knew, how much they remembered, and then use it to drive some discussion. So it would be this: name two numbers that add up to 6. And every student could give me, you know, 1 plus 5, or 3 plus 3, or 4 plus 2, and then somebody else would say, does 2 plus 4 count? Yeah, sure. Somebody would always say 2 plus 5, which is great for what we're trying to get done with this. It actually, you know, serves as a great counterexample of the whole idea of the lesson. So we would make a big list if we got 5 or 6 or 10. Then eventually we're ordered pairs. I had them write them in ordered pairs. And say, all right, now we're going to graph these on the coordinate plane. So each one had this worksheet, and we graph them. And then it would be, you know, what do you notice? What do you wonder? Ideally, they'd say, well, it looks like all these points fall in a straight line. And from there, we could take the discussion wherever we needed to go. And I think these last couple of years, we've tried to at least be able to write information. If we could pick out a slope and find a line there. So this had worked well, I think, for the purpose that I used it for. But once I discovered Activity Builder, this is one of the things that I thought, hey, you know, can we digitize this and maybe use some of the power of the tool to make it a little bit better. So this is what it turned out to be in Activity Builder. And this is a pretty raw, pretty simple activity. It's the first one I ever did. So it's not fantastic, but it got the job. And so from the teacher site, if I went ahead and went to this activity that I created, it would give me options to start a new session. If I wanted to share it out socially, there's a link that would take other teachers right to the site. A preview of the screens, and then a link that actually would show other teachers that were interested in it. Well, you know, what are the students going to see? So I think when I put this activity together, we had done the pencil paper activity first on a Friday, and then I came back on the following Monday, and we sat down and used the activity. And so as the first page, we just kind of introduced it. With each page when you create, it'll give you an option to create the text, to put images in there, to ask a question, to insert a graph, and so forth. The students would be able to navigate through using the arrows at the top. So we started off this way, just to kind of engage prior knowledge. Tell me what we did on Friday. What do you remember? Even if it was something simple, and we added up numbers, we made a graph. I'm going to open up a new tab, the students view. They'll go to the page student.desmos.com. And when the teacher launches the activity, there'll be a code for that class. Right. And last time they enter a name. We'll come back to the obvious name question in a minute. So this is what the students see. from the teacher dashboard, I'll be able to see on the left-hand side as each student enters the code and joins in their name and a progress bar. And just kind of visually I can see who's kind of jumping ahead, who's lagging behind, who's stuck, who can't get started. How many students are on each individual page is indicated. And one of the other things that happens is as the students are working their way through this, as they start to run their responses, they can see other students' responses as well.
So you can have that up and the kids are seeing what everybody else is writing. So like a Twitter feed.
Sure. And later on, when they got asked to graph,
How do you draw a line? Sorry.
no, that's good. Because part of this was some of my students were familiar with Desmos and some of them weren't. So when I say plot a line between the 2 points, now it's not just a matter of, well, do I know how to create that line mathematically, but how do I use the tools of the site to make that happen? And so counting on the fact that these guys play a lot of video games and a lot of cell phone games, and they're pretty good at sometimes just kind of finding their way through until they figure out how to make it happen. I let them struggle a little bit. The classes that need a little hint, I'd say, well, let's enter an equation. So if they click below that table, the cursor highlights and they can type in whatever they want.
So they actually have to calculate what the line is.
Right. And so depending on the level of the class, that might not happen. And so I'd say, well, let's just start by typing anything in. Let's put y equals 2x minus 1 and see what happens. So now there's a line on there, and it doesn't go through the points. And so now we've kind of let them struggle a little bit. I think we've probably reached the point where struggle is becoming counterproductive. I don't know how to make that line go between the points, which is fine. And so if they were able to do that, I asked them to give me some feedback on how they graph the line. If they were able to graph it, explain how they went about doing it. Did they figure out a slope and an intercept? Did they write the equation? If they weren't able to do that at all, one of the most valuable pieces of Desmos, one of those writing tools, I think, is the sliders. So I entered in y equals mx plus b. It asked me, do you want to add sliders? Do you want to add a slider for the m value? Do you want to add a slider for the b value? And I say yes. So now they can go take each slider, change the value. And for most of my students, once they were able to do that, they were able to snap that line with 2 points pretty quickly. And again, from the teacher side, I can see individually what each student is doing. I can see who's going to look at the line, who can't. And then this was the big payoff for this activity is, what's the equation of the line? And so having used the slider to set the m and the b, a lot of them, if they remember anything from Algebra 1a, it's y equals mx plus b. And so a lot of them were able to write the equation that way. If not, that gave me some information. Well, let's see if we can go in and think about how do we write an equation for a linear function if we know slope and intercept.
But you had to create the sliders to put on that particular page? Because they didn't show up on page 2.
Right. So I left them off intentionally on page 2 and included them on page 5 or whatever. Just from a standpoint of using the calculator in general, if you said x squared plus x plus c. So it recognizes we've got standard form equation. It says, do you want to add sliders for A, B, and C? And I'll say yes. A million years ago, when we used to use the transparency over a graph, I'd be like moving the graph around on the transparency to show transformations. I remember sitting in class and it won't be you guys, it'll be your kids. I said, your kids are going to be sitting here with a little computer that can just touch it with their finger, I moved the graph around, and they were like, I was nuts. And now, almost like 5 years later, almost the same thing here it is, which is kind of cool. The teacher dashboard gives you the option between seeing each individual student response and seeing an overlay. So all aligned and saying, hey, everybody's got this, it's great, let's move on. One other kind of cool toy up at the top. If you've got students that are really into inappropriate school names when they know they're on the screen, or students are maybe a little bit bashful about having their name attached to their work, a little spy icon will generate some fake names. So everybody's anonymous if you want to be. So that was the basics. I mean, it was a really simple, like kind of two task activity, but I think it did what I wanted it to do. Which is nice. And then the next thing that happens, I started looking at this, I was like, man, this is really great for probably algebra, pre-algebra. It looks like it'd be good for functions and linear and quadratics, but what about teachers from maybe more advanced math classes, or what else can be done with this? When I first started following Dan Meyer, one of the lessons that he had done, he went out back in his apartment building, shot video of him shooting baskets, and then did like a stop motion of the video. Right? So strobed the basketball and stopped it at the apex of its travel. And then he turned that over to his kids, showed them the picture. Well, of course, the kids all want to know to become a basket. And then he gave them an activity where they played around with, I think, GeoGebra to try to match a parabola to the path of the basketball. Well, now Dan Meyer is on the teaching faculty at Desmos, so he went back and took one of his own lessons, tuned it up for the 21st century or 2016 or whatever, and made a Desmos activity out of it. And we ended up using this just when we started to introduce quadratics this year. This one's much longer, kind of just quickly hit the highlights on it. But it started like this. Students open up a screen, they see 6 data points and 2 black points, which are kind of have the same effect of sliders. Be real honest, I'm not 100% sure how to put those 2 movable black points on. We'll figure that part out. But yeah, so the idea was, and most of the students in Algebra 1 can say, oh yeah, I think I can drag these points and make a line of best fit. Whatever they came up with, and good opportunity to spiral back. What's a line of best fit mean? Do you need to touch all the dots? Should be above, below, whatever the case. So most of the students can do this. And I think this was probably 75% of what he had in mind when he created this activity. In my class, this was a huge payoff. It's like, this couldn't have turned out better if I wrote it myself. We spent all the time in Algebra 1A showing how linear functions describe so much in the world. And then everything is linear until it's not. And we turn around and find out that there's other kinds of functions too. And so that's where this starts to. So they're all very proud of themselves. They've created this line of best fit. And then it says, okay, click the circle next to the folder to see where those points actually came from. And he's able to overlay this with the photo of him shooting the basketball. And for students in the back, or if they have a dark screen on the Chromebook, this was hard to see. The blue points track the path of the ball. And all of a sudden the student's like, whoa, hey, where'd that come from? And then it says go to the next screen. And he explains, we used to only be able to describe the world with straight lines. Now we know we might need different kinds of math to describe some other things. It says line is the wrong model here. That's a great question. What does your line say will happen to basketball? Most of my students were able to say, oh, it's never going to curve. It's never going to come back down. but they started thinking about what a definition of a line is. And they knew it was never going to hit the roof. And so the way that he set up the rest of the lesson is first using just eyesight to make some predictions. He showed 8 different shots, and their job was to say yes or no, what's going to hit the roof or it won't. And they're going to enter that in Desmos and write it down in their own notebooks. With 55-minute classes, I didn't use all 8. I think I used 4 or maybe 3, depending. But it would look something like this. You know, here's a shot. What's your best guess? Does it go in or go out? And as you know about Meyer, that's one of his big hooks is, you know, getting the students involved, guessing, you know, where the barrier to entry is low, and there's no penalty for being wrong, except maybe your seatmate says I understood.
And then when they submit, that's where you see it on your teacher.
Right, right. So we'll be able to see everybody's answers. So yes, no, yes, yes, no, no, no. And they're keeping track for themselves, because eventually what's going to happen is he gives them the tools to now fit a parabola to the path of the ball. They all found out that it's not as easy as it looks. And especially on a small screen, a slight tweak one way or the other would make a big change. And so now they can kind of see a visual path. Is this going to go in the hoop or not? And most of the students are able to say, no, that doesn't look like that's going to go in. And so now write their new prediction, and we see how their perception changed. And so again, like I said, when we did this in class, I only had time to do maybe about 4 of them out of a total of 8. And so now, again, the big payoff. And so here's the result of each one of those shots. Does this one go in? Number 1 actually goes in. For a lot of them, it was really hard to bend that parabola. It didn't look like it was going to go in at all. And it turns out that it actually did. One of them was kind of sneaky. There's a bank shot in here. So it looks like it's going to be way long, and then it ends up going in. We didn't get that far. And so with minor activities, there's always some type of extension or sequel. And so he uses this to introduce quadratics. And so then brought up some questions for his students just to talk about and think about. Things like this: how tall is the chute? What we unfortunately found out is because the background is dark, the screen on the Chromebooks are dark, and sometimes the classrooms are dark, it was really hard to see the grid lines. He's about 6'6". Most of the students guessed about 6 feet tall. And so these 3 activities, they didn't have quite the move that the earlier ones did. So that was a little more lengthy and complex example of what can be done with activity. And so we already had a chance to take a look at the teacher.desmos.com site. You can search at the top of the screen. There's also a button there to browse.
Sorry.
That's all right. And so every activity is tagged. So you can search linear, search sine, search trig functions. So if I do a search there, it comes up with maybe 8 hits. And in each case, you'd have the ability to go ahead and click the Learn More button and show you the preview of the student screen. So is this going to work for what I want? And so forth. Browse features, just rows and columns. And I think one of the things that I always find interesting when I look at the browsing page is how many teachers are out there that are taking data from the world and creating activities. Are people waiting to get married? 400-meter modeling, which is, I think, the difference in world records for men and women. NBA draft salary predictions. They're taking a lot of data out there and modeling it mathematically, and then letting students kind of get in there, crawl around, look at what those questions might be, and using the Desmos tools to come up with some answers.
So anytime you build one, it goes into the pool?
I think what happens is they've got like a teaching faculty that reviews a lot of the submissions, and ones that are good or maybe could use a little tweaking, that they'll post on the browser page. You're always free to share anything that you've done. Like for instance, if I wanted to search for the one that I think it's not. Because I think probably at some point they recognize when we get critical mass, well, hundreds of thousands of teachers creating maybe a dozen of these a year, and maybe a lot of them won't be very good.
And then, but you have for your use on your
Right, so
account. Gotcha. Yeah.
click back to my home page. Right, so when I'm logged into my account, it shows me it's my recent sessions, and I think somewhere in here is my custom activities. So things that I personally made, and I think I'm logged under my SCH login, so the one I made isn't even in there. Anything that I make would show up on that bottom row. You can favorite items in the middle of the bottom row. Never did get a chance to play around with these. These are two of the fun toys that the Desmos staff has come up with. They're both kind of gamified. So with marble slides. The idea is for the marbles to hit the stars. And they'll have an opportunity to change some of the equations on the parabolas that are in there.
Oh, but in order to change.
To get the right answer, right.
They have to change the equation.
So maybe we'll find that online. So change the sign of one number. Most of them will be able to figure out, okay, if I make 0.1 negative, this will work. And so on down the line, different forms of the equation and so forth. So a neat little thing. The other one called Polymath. Kind of like a 20 questions game for students in pairs. I think this is what I was talking about, sitting down and I never did, I think in my class schedule, find the right day to put this in on the time that I have left. Still want to use this.
Students get a mastermind.
I think a little bit, so there's maybe a selection of 20 graphs of parabolas. Student A selects one, and student B has to ask questions. Does it open up and down? That type of thing to kind of eliminate options. So there's a lot of cool stuff out there, and I think there's a lot of really good pre-made lessons that you can get students working on right away. And then, like I said, in my personal experience, I decided I'm going to jump in and see if I can make one of these and see if it works, and then go from there. And then this was the other big piece of it. Okay, what kind of lesson do I already have that would make sense to migrate over to Desmos? If I have something on pencil and paper, should it stay on pencil and paper? Or good activity builder, can I amp it up a little bit? And Meyer actually blogged about it in the middle of the school year. He went and grabbed one of his Twitter follows lessons and said, this is a really great activity that you have for your kids with pencil and paper. What if we moved over to Desmos? What would it look like? And in the first session, led to some pretty good conversations. A couple of teachers like, hey, I've been doing this. I wonder if I could use Desmos to help me make some more sense. There's nothing proprietary in the presentation, so these are links to the Desmos home site, the activity builder, teacher page, the Meyer blog page, where he wrote about picking lessons to try to move on over. Desmos keeps a blog where their teaching staff writes about new features and ways that teachers out there are using them. They also have a YouTube channel for video help. And then the last piece, to extend the learning for the day, this Math Twitter blogosphere group that I fell in with. They do a Tuesday night webinar called the Global Math Department. And so each Tuesday a different topic, and each Tuesday it's one or two teachers that will host the webinar. I think the cool features about it is, number one, like for instance, this particular one, she's another one of the teaching faculty, so she kind of talked about her thought process, how she created the activities that she's used, and then for the teachers that are viewing the webinar, there's a chat box on the right-hand side, so there's all kinds of side conversations going on. You know, this particular one, you had everything from people that were like expert level activity builder users, they're talking about their thought process when they put together their lessons, on down to people that were just really interested. Hey, I'd like to do this, but I don't know where to start. How do I A, B, C? And in the chat box, people are answering those questions. So I took a little bit of time last summer, one day a week, I just put they're an hour long. They archive them when they're done, so if I missed one, if it was something that interested me, I know I can always go back and catch it later. Kind of a neat little thing. So that's what I've got. We built in some time at the end of the first session for either question and answer, or teachers want to go in and start trying to play with the tools. Either way is fine, or to get a head start on the next line. More and more as the day went on, as you put enough smart people in one room, stuff just starts bubbling up. And just sitting and listening to Kristen this morning, I started catching, okay, I see how this fits in with the idea she was talking about. I was at the Hyperdoc presentation that Kate Bradford did. Again, it's the exact same thing. It's just a framework for creating a pathway to a learning objective. How we make the students, here's the question, what I want them to know at the end, how. That makes sense. It seems like all of today was, I see it as one big lesson design seminar, different science, different tools, same objective.